Hi, I'm Professor Goins. Welcome to the Math Professor's YouTube channel. If you're looking for videos explaining topics in college mathematics courses, please consider subscribing because you're in the right spot. That said, let's get into the current video. I'm going to talk about non-homogeneous equations, more specifically non-homogeneous linear second-order differential equations that you will encounter in your first differential equations course. And I'm going to use the method referred to as undetermined coefficients. So let's go ahead and take a look at this first example. Okay, so solution. In order to work through this method, here's the idea. I have to make a guess as to what the solution is. Now, of course, I can make an educated guess in this case. If I take this, whatever this function, this unknown function is, if I take the function, multiply it by 2, and I add its derivative times 3, and then I add its second derivative, that linear combination gives me this exponential. Now, it does not really make any sense for y to have a trig function in it, right? If I differentiate a trig function, I get another trig function. And then if I add a trig function with another trig function, I'm not going to get an exponential. Same thing with, say, polynomials or radical terms or hyperbolic functions. The idea is I'm going to have some sort of an exponential. And in particular, since this is a linear differential equation, I'm not multiplying any of the unknown functions together, like its function and its derivative. So therefore, y would have to be something of the form e to the 3t. I can't get an e to the 4t by differentiating and then adding terms. So therefore, I make the following educated guess. Y is going to be something of the form a e to the 3t. The only thing I don't know is what is a. So notice that this, ties into the definition or the term for the method of undetermined coefficients. What I do, whether this is trig functions or exponentials or polynomial terms, I make a guess that the base function or the unknown function is some combination of those types of terms, and then I write a generic expression for that. I plug it into the differential equation. I set this equal to 5e to the 3t, and then I solve for my coefficients. Let's go through the method. Y, again, is going to be a multiple of this exponential. Its derivative, y prime, is 3e to the 3t. Y double prime would be 9a e to the 3t. And then I'm going to go ahead and plug those into the left side of the equation, giving me 9a e to the 3t plus 3 times y prime, which is 3a e to the 3t, plus 2 times a e to the 3t, and there's the left side of the differential equation with those specific terms plugged in, and that's going to be equal to 5e to the 3t. Now, of course, on the left-hand side, I'm going to combine all of those. This is 9a. Of course, this would give me a coefficient of 9a, and then this right here would give me a coefficient of 2a. So that means I'd have 9a, which would give me 18, 2 more, which would give me 20. Therefore, that would be 20a e to the 3t is equal to 5e to the 3t. Okay? Now, all I have to do is solve this equation for a. Well, the exponentials are never 0, so I can divide by the e to the 3t, and then I can divide both sides by 20, which is going to give me a is equal to 5 over 20, which of course is equal to 1/4, and therefore my solution to this differential equation would be y is equal to 1/4 e to the 3t. Now, remember that we've solved homogeneous equations in previous videos where I would have a differential equation that would have terms just like this, but it would be set equal to 0. Now, since this is a linear differential equation, if I was to plug in terms from that homogeneous solution, that linear combination, these would add up to 0. That means that that actually is also part of the solution. So another part of the solution here so another part of the solution would be, and it looks like this marker is starting to die here. Let me see if I can grab another one. Okay, so the rest of the solution would actually be the terms that we could generate from the corresponding homogeneous equation. Meaning, if I take this original differential equation, I set it equal to 0, and then I'm going to solve that, those terms will also contribute to my overall solution. So let's go ahead and take a look at what that would be. Write this back up at the top so I don't forget what it was. We've got y double prime plus 3y prime plus 2y is equal to 0. So this is the corresponding homogeneous equation. And again, if you have not seen the videos, or if you forgot how to solve a homogeneous equation with constant coefficients, go back and watch the videos that I posted for using what's called the characteristic equation. So I'm just going to go ahead and use that. Characteristic equation gives me the following: r squared plus 3r plus 2 is equal to 0. And this factors as r plus 1, r plus 2 equals 0. Therefore, the roots of the characteristic equation would be -1 and -2. This gives me two terms for the solution. I'll just label this as y1 is equal to e to the negative, what was my, variable t, I was just trying to remember if it was t or x, so e to the negative t, and then y2 would be e to the negative 2t. These two terms here would be solutions to the homogeneous equation, and therefore any linear combination of those would also be a solution to the homogeneous equation, and would also contribute to the solution to the overall non-homogeneous equation. Therefore, the most general solution is y is equal to 1/4 e to the 3t plus c1 e to the negative t plus c2 e to the negative 2t. Because the corresponding linear combination of these terms, when I plug it into the differential equations, generates 0. And when I take this term, I plug it into the differential equation, that combination is going to give me the 5e to the 3t. Therefore, the whole sum of that would solve it, and illustrating the method. Now, let's start one more example. Here's another non-homogeneous equation, again, linear second order, and this is equal to x plus 4 sine of x. So what I have to do to solve this, I have to find not only the solution to the corresponding homogeneous equation, but using the method of undetermined coefficients, I have to see if I can come up with what would the term or terms be that would generate, after I take my solution, plug it into y prime, y double prime, compute that linear combination, what's going to give me x plus 4 sine x. Therefore, we have to make an educated guess. So solution. Now, if I was to take a function and take its derivative and its second derivative, what kind of things and then take that linear combination. What sort of terms could we get to generate this? Well, if I have, let's say, a polynomial term, right? Let's say I've got an x squared. If I differentiate that, I would get 2x. So I've got an x term here. However, if I take that x squared term and plug it in here, that's probably not going to cancel because the derivative would be lower degree term. So there's no way I'm going to be able to cancel an x squared, and I don't have an x squared term over here. Therefore, what I'll do is I'll take with the polynomial terms, whatever the degree of those polynomial terms is, and I'm going to write a most general polynomial of that degree. Meaning, since this is first degree, I'm going to write this as ax plus b. If this was an x squared, I would put ax squared plus bx plus c, so on and so forth, if I had higher order terms here. Now, I have to somehow take a linear combination to get a sine function. Now, let's just say I pick just sine. I'd have a sine here. This would give me a cosine. This would give me a sine. But I'm going to somehow have to be able to cancel that cosine. Therefore, what I would have to have is some combination of, say, c sine x plus d cosine x. If I have a sine here and I differentiate that, I'm going to get a cosine. So I have to kind of incorporate every possible derivative of that base function throughout this expression. So if I had a, and then if I had an e to the 2x, I'd have to have a plus e to the 2x here. Okay, so now let's go ahead and plug this in. Well, before I plug it in, we have to take the first and second derivative of this. That would give me y prime is equal to a, right, that'd be 0, plus c cosine of x minus d sine of x. And then y double prime would be negative c sine of x, and then minus d cosine of x. Okay. So then what I'll do is I'll take these three terms here, plug it into the left side of the differential equation, set it equal to the right-hand side, and then we're going to have to match up the coefficients. Okay, so this is going to, let me kind of separate this here visually. Okay, go ahead and plug things in. I would have negative c sine x minus d cosine of x. That's the second derivative, minus 2 times y prime, which is a plus c cosine x minus d sine x. Right, so there's y prime, minus 3 times y, which was ax plus b plus c sine x plus d cosine x. And that spans my whole board here, so I'll just put this down here. This is equal to x plus 4 sine of x. Now what I have to do is let's combine like terms on the left-hand side, and then we'll match up coefficients. All right, so if I go through this whole string of terms here, I need to combine, let's say, the x terms. The only one would be here, which would be negative 3ax. So we have negative 3ax. The next one would be the constant terms. That would give me a minus 2a and minus 3b. Now let's combine the sine terms. So I'll put plus, we've got negative c. Here's another sine term, negative 2 and negative d would be plus 2d. And then another sine term here, which would be minus 3c. Of course, we can combine those, but let's just leave it at that for now. And then plus, let's combine the cosine terms. We've got minus d plus 2d. Cosine terms. That'd be minus 2c. Cosine term here, minus 3d. this is cosine, this was multiplied by sine, and that's equal to x plus 4 sine of x. Okay. Now let's see if I can at least get the equations up here before I have to erase. If I match coefficients up, I see that negative 3a is going to have to be 1. So I have negative 3a has to be 1. Now there's no constant term here. Therefore, this constant term, negative 2a minus 3b, has to be 0. And then this term here, which is in front of the sine function, is going to have to be 4. And of course, I can combine the negative c and the negative 3c. That gives me 2d minus 4c is going to be equal to 4. Now, there's no cosine term over here, so this coefficient has to be 0, which means I would have negative 4d minus 2c is equal to 0. Now, once I solve this system of equations, we have our a, b, c, and d. Then I just go ahead and plug them into this general expression right here, giving me the solution to the non-homogeneous portion. So let me go ahead and, let's see, I can probably clean up. I'll leave these equations up here, and I'll leave the general expression. Everything else I'm going to go ahead and erase. All right, so let's see here. First and foremost, this tells me that a is going to be negative 1/3. And then once I have negative 1/3, I can go ahead and plug it in down here, because this is going to say, if I say add 3b to the other side and divide by 3, I get b is equal to, so that'd be negative 2/3 b, or sorry, a. Right, let me just double check that. If I add 3b over, I isolate the b term, I divide by 3, that'd be negative 2 over 3a. A, of course, is negative 1/3. That gives me negative 2/9 for b. And then 2d minus 4c is 0. Let's see, we have a, we have b, and then it looks like we would have to solve this as a system of equations. So let's say I was to take this second equation and let's multiply it by negative 2. That's going to give me the following: 2d minus 4c is equal to 4. And then multiply this by negative 2, I get 8d plus 4c is equal to 0. And then if I add that together, I'm going to get 10d is equal to 4. So d would be 4/10, which is the same as 2/5. So there's the value for d. Given that, I can go back and plug it in to either one of these equations to solve for c. So say I plug it into this one. Let's isolate the c term first. If I add 4c and subtract 4, I get 4c is going to be 2d minus 4. And double check that. Add 4c, isolate the 4c term, subtract 4 over, I get 2d minus 4. Okay, so that's good. Plug in 2/5 for d, so I get 4c is 2 times 2/5 minus 4. So 4c is 4/5 minus 4. 4c would be 4/5 minus, that'd be 20 over 5. 4c would be negative 16 over 5, and therefore c would be negative 4/5. Okay? That gives me the following general solution to the non-homogeneous portion. I get y is equal to ax, which was negative 1/3 x, plus b, which is minus 2/9, plus c sine of x. C was, let's see, we're negative 4/5, so I'll make this a negative 4/5 sine of x, and then plus d cosine. D was 2/5, so this is plus 2/5 cosine x. So this right here would be the part of the solution that corresponds to the non-homogeneous portion. Now what we have to do is find the solution to the corresponding homogeneous equation, which again is y double prime minus 2y prime minus 3y is equal to 0. I just take the differential equation, set it equal to 0. Characteristic equation, r squared minus 2r minus 3 equals 0. That factors as r minus 1. Let's see. Nope, let's do r plus 1 and then r minus 3 equal to 0. That gives me roots of -1 and 3, which gives me the following portion of the solution, which gives me the solution to the to the homogeneous equation. Y is equal to c1 e to the negative, we use the variable x, e to the negative x, plus c2 e to the 3x. And these two boxes combined give me the most general solution to the initial differential equation. Okay. Thanks for watching, and please consider subscribing.